This time we have Stephen Thair. Hi, Steve.
Hi, Florian. How are you?
It was a short break. I'm good, thank you. How about you?
Yeah, looking forward to it. Can't wait.
We're looking forward as well. So Steve, I'm really glad that we have the chance to meet remotely in person. We're part of the same Microsoft Regional Directors Program. So I have to confess that I'm following all your interventions in the internal community channels. Very thoughtful and very wise advice I'm seeing there coming from you.
Thank you.
So, Steve, what's DevOps Group? What are you doing there?
So DevOps Group is a company I founded about 7 years ago, or co-founded about 7 years ago, and really we're about helping organizations adopt cloud and DevOps. We were pretty early adopters into this space, so yeah, we've been around for a long time, and we've watched the evolution of DevOps, which is really part of what my talk is about how the role of ops is evolving, as part of a DevOps movement, which is now 11 years old.
Absolutely. I was wondering, the landscape is enlarging in terms of ops things. So now you have data ops, you've got ML ops, you've got QA ops, you've got fin ops, win ops, and so on and so forth. So after all, what are all these terms, names?
I normally find that most of those terms, and we'll talk about no ops in my presentation, but you'll find that most of those terms are coined by marketing people who have a tool to sell you. I mean, all of those things are just operations applied to a vertical market or operations applied to a particular technology. The things that operations need to do remain the same. We've still got to deal with incidents. We've still got to deal with, stability and throughput, like Dave said in his presentation earlier. I think those marketing terms, I wish they wouldn't do it. I wish they'd just stick with, as much as possible with DevOps. Admittedly, I do talk about WinOps, but so I'm not following my own advice. But
okay, I got it. So in terms of this special period, the pandemic, have you seen anything in particular in the DevOps area? I don't know, some sort of an acceleration of the things, or I don't know, something particular?
So we ran a quick little survey on LinkedIn. We got about 120 responses, and we asked people 3 questions. Is as a result of the pandemic, are you looking to accelerate your sort of cloud and DevOps adoption, keep the rate of your cloud and DevOps adoption the same, or slow down your rate of cloud and DevOps adoption? And it was about 80% said accelerate, 20% said keep the same, and nobody said slow it down. So I think absolutely organizations have looked at the organizations that have that continuous delivery ability that Dave was talking about, that have the DevOps capability, were able to pivot faster when lockdown happened. They were able to provision remote working faster. They were able to scale up or scale down their production systems, to match the changes in load that they were seeing. So I think there's a lot of good evidence that those organizations that were already mature on their cloud and DevOps story had a better lockdown, for want of a better word. And that also positions them to, as we hopefully start to accelerate out of the pandemic in 2021, they'll be in a position to accelerate faster and move ahead even more.
Well, that's great. Good for business, good for people. I'm going to slowly fade out, actually, and I'm going to leave you the floor. So thank you. And
no worries.
Thank you.
All right. Alexa, set a timer for 45 minutes. Right, let's get going. So, hi everybody. Hopefully you can all see my screen and we're good to go. So, the agenda today is really to talk about the future of operations within a DevOps and cloudy agenda. We're going to talk about, does operations have a future? What's ops going to be doing in that future? How are we going to be doing that thing in the future? I've got 74 slides to get through in about 45 minutes. And even my summary is 15 points long. So this is going to be super fast paced. We will share the slides at the end of the session. So, you know, stop what you're doing, listen up, pay attention, and let's get going. So as Florian said in the introduction, my name is Steve Thair. I'm the CTO and co-founder of DevOpsGroup here in the UK. I'm a 30-year industry veteran. I used to run high-volume websites, in particular, at the time was one of UK's highest volume websites, which was Total Jobs, and the Total Jobs family of job websites, like the UK equivalent of monster.com, if you're not familiar. So my company, DevOps Group, is about making cloud and DevOps fast, secure, and simple for both you know, high growth scale ups and also enterprise organizations. We've got a very enviable client base. So in the 7.5 years we've been doing this, we've learned a lot about what works and what doesn't work in the cloud and DevOps world. So let's dive into this. Does ops have a future? You know, what are people saying? I'm going to start with the great no ops controversy of 2011. Basically, a guy named Mike Galtieri from Forrester Research published a blog post, said, I don't want DevOps, I want no ops. And I think it's probably fair to say a lot of people on Twitter and in the conversations, they saw the term no ops on a tweet. They didn't actually read the article and they lost their minds. I mean, it was a bit of a tweet storm, a blog storm. There was a lot of controversy at the time. People going, sky's falling, ops is dead. You know, we don't need operations people anymore. You know, this thing. I mean, there was, you know, dogs and cats living together, mass hysteria, panic. You know, so we're going to talk a little bit later about what Mike actually said and what he wanted, you know. But, you know, there is a valid issue here in what he was talking about, which is that automation is having an impact at every level in every industry and in the IT industry as well. And ops is no exception to this. In 2013, there was a study from 2 Oxford academics, Frey and Osborne, that studied the impact of automation on different job roles. And so one of the job roles they looked at was the IT operations technician, the standard occupation code 3131. And they said within a sort of a 10-year type horizon, how likely it is that these jobs would be automated away. And their assessment was that it was in the top 30. It was fairly likely, 78%, that that job, based upon its job characteristics, would be automated away in the next decade. That's pretty scary, you know, on the face of it. But you know, we also know that we're looking at cloud and we're seeing this direction of travel in cloud. We've gone from traditional on-premise, where we were responsible everything from the physical layer all the way up to the application, the full stack, the data center, the heating, ventilation, air conditioning, power conditioning, generators, all of those things that we were responsible for in a traditional data center. We also have, you know, and then as we're moving into infrastructure as a service and platform as a service, the direction of travel of the industry is fairly clear, and that is increasing level of abstraction. Certainly abstraction away from the physical, now extracting it away from the data center. You know, so we have to accept that as we move to the cloud and as we adopt all these new DevOps technologies, that our roles are going to have to change. I mean, we have a graduate program in our company. We've had it running for 5 of our 7 years. And so a person who is entering the IT industry today will never install an operating system from scratch. They will never rack a server. They will never swap out a failed disk drive or rebuild a storage array. And pretty soon, none of you will either. You know, that part of our traditional roles as operations is going away, and we need to evolve with it. But, you know, so all this furor around no ops is happening. But, you know, in reality, back in the real world, I think my first message, now that I've probably worried and terrified everybody on things, my first message is don't panic, okay? This is not the reality. Ops is not going anywhere. You know, there's plenty of people with a much stronger operations pedigree like me, like John Allsport, you know, the man who with John Hammond kickstarted the whole DevOps movement at Velocity Conference presentation in 2009, 10 deployments a day at Flickr, you know, and has run some of the largest volume websites in the world. You know, he was pretty clear, no ops beats cloud, agile, and SOPA as the dumbest marketing term ever coined in my field. You know, and so just panic, don't relax, ops is not going anywhere. And to be fair to Mike from Forrester, what he actually said in the original blog post was no ops will achieve this nirvana by using infrastructure as service as a platform as a service. Ops will still run this. Oh, hang on. So in your no ops, you still need ops to run these platforms and give developers the tools they need to responsibly deploy applications faster. Perfect follow on from Dave's presentation. The ops people are going to be building the platforms that give developers the tools they need to responsibly deploy applications faster. And by extension, in a DevOps world, and then have some degree of responsibility for running them in production 24/7. We'll talk more about that in a minute and what that really means. So funnily enough, if you read the Google Site Reliability Engineering book, the SRE book, this is actually what they call platform SRE. It's chapter 32. Provide product development, the developers, with a platform with SRE validated infrastructure which they can build their systems. That will be both reliable and scalable. It will have that stability built in, the scalability built in, the quality built in, the compliance and governance and security and all of those things that we need built into this platform, which allows the product development teams to focus on innovation at the application layer where it mostly belongs. Focus on the product, focus more importantly on the customer and the customer needs, doing all those experiments that Dave was talking about in order to delight your customers and grow your business. Funnily enough, we DevOpsGroup have been talking about platforms for about a year before the SRE book came out. And this is actually the evolution of a diagram I did for a customer back in 2015, which shows very clearly this idea of platform teams that are offering up self-service platform as a service. They're creating templates of shared Git repo using what's called an enterprise shared source, or now more commonly called an inner source model, that in this library of Puppet templates, of Terraform playbooks, of internal Docker registry of validated templates, whatever's that pattern that might be, you have them in the repo that are shared between the two. People can contribute to these things, just exactly the same way as they would contribute to an open source project. And as well as you have these curated platforms that you are managing on behalf of the delivery teams, the product teams, to offer them up as a service. And, and all of this is really just an evolution of our roles. Our roles have constantly, as operations people, have constantly changed and evolved. When we went from mainframe, you had a mainframe system programmer that was using punch cards and JCL, running OS 360 IBM environments in the 1960s. Evolved into mini computers, evolved into client server, and suddenly we're running large on-premise and colo data centers at scale. That is now evolving into cloud. I think what is key to really understand here for anybody who's worried about this no ops or where's the world going message is that the demand for IT services is only going in one direction, and that direction is up. Microsoft, during the lockdown, launched a digital skills initiative to try and help 25 million people acquire the digital skills that will be needed in a COVID-19 and a post-COVID-19 economy. And based on their analysis, and just remember that obviously Microsoft owns LinkedIn, so they've got access to a huge amount of data about job roles and job adverts and who's looking for what sort of jobs. They predicted that they'll need 149 million new jobs in the IT industry by 2025. And if you think about, they're saying that currently there's only 41 million, and we're going to 190 million. I mean, that is an incredible growth rate. If we drill down into cloud and data roles, they're predicting a 280% growth in cloud and data roles in the next 5 years. So there will be this incredible demand for operations roles. There will be an even more incredible demand for software developers. So this idea that suddenly software developers are going to come in and take over all the operations roles, or all of the operational responsibilities for running systems are suddenly going to be handed over to developers, and there'll be no ops and we won't need ops anymore, it's just utterly ridiculous. So you know, be reassured that the future of ops is bright, the future of ops is rosy, but we do need to evolve. We are going to be doing things in a different way, using different tools, and we're going to have a different relationship with development and a different relationship with the business. But I think when we talk about this evolution, we need to remember that we have lots of existing skills and knowledge that's still valuable. We are not throwing out everything that we ever knew before and starting from scratch. We are starting from a great foundation of fundamental knowledges of how to do certain things and how to approach problems and how to approach those, you know, crisis level incidents. Susan Fowler, who's famously worked for Uber, wrote a blog in 2008 on the ops identity crisis. And she got two things right and she got a third thing wrong. But there's three domains of expertise that experienced operations engineers tend to have. They tend to have lots of low-level systems knowledge. You know, I've never really met a developer that really understood TCP/IP very well. Arguably, most of them don't even actually understand HTTP very well. They don't need to, because it's been abstracted away by the libraries they use to call into the system, and they've been abstracted away from that underlying network architecture. But even in the cloud, you still have to create these networks. You still have to understand subnetting and load balancing and layer 7 sort of switching. There's so many things you still need to understand, even working in the cloud. The second thing is they tend to have a lot of high-level distributed system knowledge. They know how the entire production systems fit and work together. We know how to design for scalability and reliability. We know how things should be deployed and monitored and logged. Yeah, I'm agreeing with you, Susan, 2 out of 2. The third one, however, they also have solid programming skills. They know multiple languages quite well and can easily write applications and tools for developers to use. I've got to say there's a lot of full-time professional software developers that I know who don't know multiple languages very well. They often tend to know one language. You know, they might know C#, they might know Java. This is a very Silicon Valley view of the world. And if there's one of the big takeaways you take from this presentation is that Silicon Valley is not the real world. So what Google does and what Netflix does and what Facebook does probably doesn't apply to you. Have a think about their goal, have a think about what they're trying to achieve, but don't just copy what they do. Because the idea that operations people suddenly have multiple programming language skills is just not reality. It's that whole, you know, unicorn doo-doo as we see. You know, so what does this mean for your ops career in the future? Am I expected to become an application developer? No. You know, you are not expected to be somebody who is interchangeable with a developer from the product team. That is just not realistic. With the growing demand for software developers, there isn't enough software developers to go around. There isn't enough operations people to go around. We're not trying to make people who are interchangeable between the two. It's just not realistic. Am I expected to acquire development skills? Yes. You should be able to use Git-based source control. Your code should be in source control exactly the same way as the developer's code, whether that's a bash script or PowerShell or whatever it may be. Should you be able to understand, build, deploy CI/CD pipelines for both your infrastructure as code and to support the developers to release the application codes? Yes, you should. Should you understand test-driven development and testing frameworks like Pester for PowerShell? Yes, you should. Should you have a fundamental understanding of software development methods and practices like Agile and Kanban? Yes, you should. Should you become proficient in at least one scripting language? PowerShell is probably the one I noticed. Yes, you could. Yes, you should. Would it be sensible to have a foundation level knowledge of at least one object-oriented programming language, C#, Ruby, Java? I would say yes. I think that that's probably a really important skill to understand so you can have a better conversation with your developer community. You need to understand how that language is compiled, how that language maps onto the real world responsibilities that you have to run and manage that system. You need to be able to know how to inspect that code. You need to know how to debug that code. You need to understand what a method call is, because that's the kind of level breakdown you're going to get from an APM tool like AppDynamics or New Relic, for example. But most importantly, we need to focus on becoming what's called T-shaped. So T-shaped is really sort of a HR concept, which is saying, yes, you have a deep functional specialization in a given application domain, or a given area of cloud. I used to be, back in the day, used to be a specialist in IIS, Internet Information Server, or Windows. I knew that back to front and sideways. That was my deep functional specialization. But we are expected to be T-shaped. We're expected to have the ability to work outside of our core area as part of a multidisciplinary team. And one of the big messages of DevOps is this concept of a multidisciplinary team. So, the challenge here is to be curious, learn about these new things, take this opportunity to have a conversation with somebody who's a test automation expert, somebody who is a conversation with a developer, somebody who's more of a front-end dev, a back-end dev, a database developer, a DBA. Learn a little bit about that area so that you can have a common language, a common understanding, and ability to have something meaningful to talk about, so that you can work more effectively as a member of the team. So what's operations going to do in this brand new, complex new world? Largely, we're going to keep doing the same things we've always done. If you're familiar with the ITIL framework, which is very, very popular in the enterprise historically as a way to run and manage, particularly the operations side, the run side of the business, the service management side of the IT department. We see these common things: event management, incident management, problem management, capacity management, availability management, all of those kind of things. If we look at the evolution of this into ITIL v4, we see the same things. Incident management hasn't gone away. The need to do monitoring hasn't gone away. The need to be able to reliably deploy something into production. So we reduce that, we improve that stability, we reduce the change failure rate that Dave was talking about. We still need to do that. If you look at the SRE book, they talk about the service reliability hierarchy. Again, we see the same stuff: monitoring, incident response, postmortems and root cause analysis. How do we do testing and multiple ring release or canary releases? How do we do capacity planning? Same stuff. Same, but different. We are just doing, the core things. We look at the 5 pillars of the well-architected framework, which is promoted by both Amazon and Microsoft. They talk about operational excellence. We talk about security. They talk about reliability. They talk about performance, efficiency, and performance as a whole. And they talk about cost optimization. Same stuff that we've been doing for years. So we're not starting from scratch. A lot of the things that you know and the things you understand are really as valid today as they will be tomorrow. You're just going to probably use different tools to do them. So I like to pull this all together into something, which is called operability. I don't like the term non-functional requirements. I like the term operability. Which is the ability to keep a piece of equipment or a system, in our case, a software system, in a safe and reliable functioning conditions according to those predefined operational requirements. And, I think as our role as operations engineers is evolving, we're going to make this, ensure that the system is operable, and then we're going to operate it. But I think we're going to be putting a lot more of our focus on the first part, making sure that the system is operable by design, than we are going to manage an unstable application in production. Nobody can afford to manage unstable applications in production anymore. It doesn't scale very well. So, part of the DevOps message is bringing these operability concerns, having a seat at the table during design time to say, hey, let's make sure that we build this in a way that is operable. Operability, there are so many dimensions of this, very similar to the dimensions we saw earlier in ITIL v3, v4, site reliability hierarchy, the well-architected framework. But if you have a look, all of this should be recognizable to you today. It's just moving to the cloud is not magically going to make these concerns go away. What it will do is make some of them far, far easier. I mean, historically, back when I was doing data center-centric work. If we wanted to set up data replication between two data sites, or file, block level replication on a SAN, stretched between two data centers, this was a complicated challenge. This required, months of effort. It required implementing third-party hardware. It required provisioning hardware, making sure you had the right capability. Now, in the cloud, if I want to make something locally redundant across two multiple availability zones, and then making actually geographically, globally redundant, it's a couple of clicks. It's that easy. It's one PowerShell command or one change to a Terraform template. So the way that we're going to do it is going to change, but many of the concerns are not going to change. One concern of operations, which I think is going to become more and more important, is what I call systems thinking. We are going to have to be, there has to be somebody who understands the big picture, somebody who understands the end-to-end flow across all of the different elements of our distributed system. And for a number of reasons which we're going to come on to, that's not going to be the developers anymore. This understanding, what science fiction terms they call grokking, understanding at a deep level as much as you can, and there are limits to how much you can understand, but understand that whole thing. I think that's really, really important. And again, this scientific generalist, as it says in the quote on the right, which quote dates back to 1957, by the way, is about maintaining a broad output, reinforces that message about being T-shaped. So why is this becoming even more and more and more important today? It's become more and more important today because we are seeing the rise and rise and rise of microservices. Organizations are trying to take their monolithic application and break it apart into some more manageable chunks that are loosely coupled, that can be released and updated independently of each other. And there's lots of very, very good reasons for doing this. And I'm going to have to give you a quick rant alert. We're going to have a little rant about microservices. Microservices, for those of you familiar with the movie The Princess Bride, you keep using that word. I don't think it means what you think it means. Microservices is probably the worst architectural pattern ever developed. Okay, and that is because the complexity of a system goes up to the square of the number of moving parts. If you take that thing that was one thing and break it into 100 things, it is now much, much, much more complex. And we'll talk about that in a minute. But microservices, the reason behind microservices is a manifestation of a thing called Conway's law, which is that your software architecture tends to manifest the organizational design that was of the teams that were building it. And microservices is effectively a reverse Conway's law. It says we're going to pull our application apart into these microservices, and then we are going to have these multidisciplinary teams that own these services, that own these long-lived teams. So if you are going to do microservices, you have to do the organizational model that goes along with it. Doing one without the other will massively increase your complexity, and as I'll show in a minute, massively have impacts on your stability. Right, back to the scheduled talk. Okay, Wood's theorem. And if you haven't been to the Snafu Catchers website and read the Stellar report, I absolutely recommend that you do. It's an amazing piece of work that just brings a whole bunch of different knowledge from safety and high reliability and critical systems thinking into IT operations. Really mind-blowing stuff. But what Wood's theorem says is that as we shard this system, as we make the system more complex, as we split it apart into microservices, as the complexity of a system increases, the accuracy of any single agent's own model of that system decreases rapidly, i.e., you can't keep it all in your head. If you think you understand how that complicated distributed system is wrong, you are almost certainly wrong, and your mental model of that system is incomplete. And in fact, it gets even worse to that, and people are starting now to talk about things called complex adaptive systems. In a complex adaptive system, you can't know everything about it because even if you had a perfect understanding of each one of those 100 microservices, that doesn't mean that you have a perfect understanding of the system's behavior as a whole. The whole is more complex than the parts. The behavior of that system is adaptive because all of those combinations of various different things that have been going on and all of this communication that's going forth between the 100 different individual nodes in the system is not really deterministic. Nobody really understands and can understand. It is a non-linear. If anybody's familiar with physics, the butterfly wing effect, a small change in some of the initial conditions can have a big impact on how the system works. Right, and one way of understanding this is a system called Cynefin, which is invented actually by a Welsh guy, which is where my company DevOpsGroup is headquartered in Cardiff in Wales. And it sort of divides systems up into sort of 4 areas. This simple area that we sense something, we can categorize it, we can respond to that. This is the if this, then that. This is the area of runbook automation. If this occurs, do that. I know exactly how to solve that problem. In the complicated space, oh, I'm not really sure. I need to do more time. I need to do more sensing. I need to gather more data, but I can still get there by analyzing. It's the area of good practice. Complex, now I might have to actually start changing something. So I'm not really sure how this whole system works together. I'm going to probe it in response. And obviously in chaotic, it doesn't really matter, do anything you want because you're going to have to change something. What we are seeing with event-driven automation and DevOps automation as a whole is the idea is that we're going to try and automate away the simple. And we're also seeing that our sharding of all of these monolithic applications to build our new cloud native applications, or to do app modernization of our cloud existing applications into cloud native applications, is moving a lot of this stuff up into the complicated area. It also means that from an operations perspective, if you think about it, if 90% of your incidents are automated away because they're in the area of simple best practice, if this, then that, fix it yourself, that's great. What that means is that when something bubbles up to actually needing our attention, it's probably going to be more complex. It's going to be more complicated. It's going to take harder. And I'm indebted here to Charles Betts from Forrester, introduced me to this idea. When you automate away the simple, all you've got left is the complicated and the complex. So the failures that we are going to have to get involved in, that we are going to perceive, are going to fail harder for longer. Your MTTR for those, you're going to end up with a sort of a bimodal distribution of failures. You're going to have a whole bunch of small failures that are resolved very quickly, and a whole bunch of big failures that are really, really, really difficult to debug and fix, because we don't have a great mental model of the system, and the properties of that system are emerging. Let's take another look at our monolith. So let's say our monolith has an availability 3 nines, 99.9. So that's pretty good. We go in and we shard the system into 100 services. Each one of those services has a 99.9 availability, same availability. What's the overall availability of that system now? Well, it's 99.9 to the power of 100. Unfortunately, the overall system is now only 90.5% availability. In order to get 99.9 for the whole system as a whole, each component now needs to have 5 nines availability. So 2 orders of magnitude higher for each individual microservice than I needed to have maybe back in my monolithic days. Now, this is a little bit of a straw man, but I'm trying to make a point here, is that effectively, the more complicated the system becomes, the more you shard it and into different parts, the more moving parts in this system, the system will be in a constant state of failure. There will be no point in time where everything is running perfectly. You know, so your mindset, this is the message of Netflix's Chaos Monkey and the Simian Army, if you've heard of these tools that they run in production that will randomly shut down various services across their estate, because they know that, hey, I'm living in a constant state of partial failure. now I'm actually going to have to make sure my systems are robust, make sure my monitoring, make sure my resilience, make sure my high availability, all of those things which are core operations concerns have been built into this application. And if I've done that, and the platform on which the application runs, and if I've done that, I'm not worried if some random thing is going over there and turning things off and on, because I know, and I'm testing myself and testing the application constantly. Okay, so let's have a think about what actually an incident means in a complex adaptive system. I'm going to have to pick up the pace. Right, there's a concept from scuba diving called the incident pit, which is basically a way of saying that when the excrement hits the oscillating blades, your decision-making ability gets worse. As you go further down and the longer the duration, the sides of this pit get steeper. So when you try and troubleshoot that outage in this complex system, you're under pressure, it's time critical, the boss is there, you're losing money, and there's this gap between your mental model of how things work and the reality of how things work. And in fact, you probably can't know exactly how things work because it's a complex adaptive system. This gap is going to bite you hard, and the only way out of this is do what scuba divers do, which is train for this stuff. Train taking your mask off, train taking your regulator out of your mouth. This is why you do game days. This is why you do constant training. This is why you run Chaos Monkey. This is why you do great post-mortem, so that you can learn from this stuff, and maybe you can move some of this stuff from the complex to the complicated to the simple and say, yeah, now I understand that, I'm going to automate that away. But what's really even more important is training yourself to be to make as many decisions about what are you going to do in a given situation before the situation occurs. Have a playbook for how you're going to run the incident, not just a playbook for the technical challenge that you're facing. You're going to have to learn to deal with the pressures the same way firefighters do, the same way any first responders do. You've got to deal with the mental as well as the actual technical side of things. But another thing we can do is build the tools and systems to help. And one of my team, Ed, phrased this really nicely when we were talking about monitoring and various other systems. Stop telling me that it's down, tell me how to get it back up. Wouldn't it be great that that when your monitoring system came up with an alert, it told you specifically what was wrong and how to fix it? It might be that thing should have or could have been automated away. It might be that it just gives you an option to say, click this button to resolve this issue, because I'm going to run this Puppet script or this piece of Terraform or whatever to handle that thing. But for whatever reason, you want to keep the operator in the loop. So the challenge, and what we're starting to see, is organizations that are taking the monitoring triangle here of synthetic transaction monitoring, APM, log analytics, service monitoring, all of that stuff. And the goal here is to try and add AI on top of it. We will need machine assistants to help us make sense of the entire system that we're running. And, this is why the future we talk about being AI augmented. We're still keeping humans in decision making because humans are very, very good at spotting patterns and doing things in a way that sometimes machines can't. But it can help to get the AI to crunch a lot of this number that would simply take you, some of this data that would simply take you too long to do. And this is also part of a wider trend to abstraction as we move further and further away from the plumbing of running the hardware and focus more and more on managing complex distributed applications. I mean, this is a simplistic viewpoint, but traditionally ops, people thought of ops as the people who managed the servers. And yes, we did have application support responsibilities as well. But I mean, broadly speaking, bear with me for this simplification. But now what we see is the ops person manages the orchestration layer, which manages the servers, paths, containers. I mean, most famously, Kubernetes is what people think of when they think about an orchestration layer. But we've had various different levels of these kind of management tools and indirections in the past. And in a future state, we're going to be training the AI that is going to manage the orchestrator, that's going to manage the servers and containers and paths, platforms in which we roll our operations. So, but in the meantime, on the day-to-day, there's still a huge amount of work to be done to build the everyday automation, particularly if your organization has not adopted DevOps. And I'm talking about the classic stuff: infrastructure as code, configuration as code, policy as code. There's a new open policy agent framework, and HashiCorp Sentinel, or Azure policy, or AWS organizations has policy that you can build. We're going to be building these code pipelines. We're going to be doing orchestration with tools like Kubernetes. We're going to be doing event-driven organization with tools like Puppet Relay. That give me some of that simple if this then that. But as again we take these simplistic systems and these stacks, we're going to start to build AI and ML on top of it to augment and make us to be super powered, basically. So, okay, we'll talk about what we're going to do, but how are we going to do this? Let's talk about new ways of working in the operations environment. And the answer, obviously I'm going to say this, the answer is DevOps. DevOps defined. If you look at the Amazon definition or the Microsoft definition, it's very similar, pretty much the same view of the world, but it's the people, process, and technology delivery of value to customers. But when we drill down into the operations space, we kind of get two competing worldviews. We get the Amazon worldview of you build it, you run it. This multifunctional delivery product team that runs long-lived products, has all the operational capabilities firmly built into the team. You build it, you run it. On the other side, we have the site reliability engineering, the SRE team. An SRE team is responsible for availability, latency, performance, etc. All those things we talked about in the what we're going to do before. And SRE is probably much more closer to the concept we had before about we're going to build these platforms and we're going to provide you with this platform for running your applications, and we're going to create templates for you and patterns and practices as code in a code repo. And we're going to build these pipelines, so platforms and pipelines. And we're going to do this as both part of a multidisciplinary team, because we will have operational people embedded in these multidisciplinary teams in both models. Whether you go SRE or whether you go you build it, you run it, there's still going to be people in teams that are going to be able to need to respond to incidents and need to understand how the application maps onto the computing infrastructure underneath it. So let's gonna dive a little bit quickly into some SRE basics. First one, hire only coders. Yeah, Silicon Valley again. Only 5% of, about 5% of ops works flow to the dev team and all overflow. We'll talk about more of that in a minute. Practice, postmortems are fun. But as you can see, that Silicon Valley unicorn thinking has made another appearance. If we jump forward into Stephen Thair's presentation in 2018, where he talks about we need service level objectives with consequences, we need time to make tomorrow better than today, we need to have the ability to regulate their workload. So service level objectives, most commonly people talk about the error budget, a way of if you exceed your error budget, which broadly speaking exceed your availability thing, you will not be allowed to deploy anymore until you either over time your reliability, your availability comes back up above the threshold, or you take some other form of corrective action. But this is an example of a type of what they call back pressure. It is a way for saying in production this system has failed, in the same way that in a distributed system that we would build this into our application. And I highly recommend reading Jeff Hodges' Notes on a Distributed System for Youngbloods. I thought it was excellent. But it's a mechanism to say, actually, actions have consequences, product team, and if you're shipping crap code, you're going to have some consequences. But it's also, I think, a conscious recognition that many application teams were very, very overloaded with incident work. We were too busy fighting fires to make things better. We need to get away from that kind of mentality. We need to set hard limits on how much time we're going to spend fighting fires and how much time we're going to spend on finding who's starting these fires and stopping them starting those fires. A lot of this is tied up in the idea of toil. How do we get rid of this boring, manual, repetitive work that scales linearly? How do we get eliminate that? Short answer is we automate the living heck out of it. Regulating workloads, 5% of these events go to the product team. All overflow events above 2 events per shift go to the product team. And the product lifecycle allows you to hand services back, which is an amazing concept for a couple of reasons. And I'm going to touch on this thing. You know, it's almost a little bit, you know, you build it, you run it. It's in an SRE model. You break it, you fix it. You know, imagine if you'd ever been in a situation where you were able to go back to and say, no, this application's crap, we're not running it anymore. You're now responsible for running it. That's what the SRE model talks about. And it talks about this process of slowly improving the stability during the creation phase. You know, have a launch readiness review. We start running it with customers. It's still self-run by the development team. Slower level of improvement, but we're still improving the stability. Eventually we get into a handover and suddenly it's taken over by the SREs. You continue to release these applications, you know, and continually be, and the SRE team is going to be continually trying to improve the stability. If you are interested in doing this, we do have a great tool, by the way, a production readiness checklist at DevOpsGroup.com, which you can go to do a production readiness review. But when things go wrong, you hand it back. Now, this should be pretty rare and it's not the right thing to do, but let's just say you have a massive, you do a release and it exposes a massive stability and issue, and it's beyond the scope of SRE to fix it. Well, in that model, you would hand it back to the existing product team to self-run again until they can get that stability above their threshold. But the big implementation of this is in a project-related model where you've brought together a bunch of developers, they've built a service, they've thrown it over into operations, and then all sorted off again. All the contractors have gone, and all the teams have been dispersed and been pulled onto another project. Who would you hand it back to? So the implication here within this SRE model is that the product teams are long-lived teams that maintain this, you know, at least 5 to 10% and all the overflow responsibility forever. That means there has to be a stable product team for you to hand this application back to, which is a big if for a lot of organizations. Right, just to wrap up, 15 quick points. Our ops roles are here to stay. No ops is a Silicon Valley fairy tale. Automation and cloud will change both what we do and how we do it. Platform ops and empowering self-service is critical to the future. Operability is even more important. The world is getting more complicated or complex. Applications and distributed systems are becoming more complex. Your mental model of how the system works is wrong. Just because you understand all of the parts to 100% perfect accuracy does not mean you understand the whole of the parts. Automation is going to help by taking care of that simple. The perception of ops challenges is actually going to change because we're only going to be we're going to be dealing with those really gnarly, complicated, emergent, complex and complicated projects. You know, when failures happen, they're going to be novel, harder to troubleshoot, and have a much higher mean time to recover. And we've got some great lessons from SRE if that's the model that you want to adopt. We've got to build in the feedback loops and back pressure with error budgets. We're going to eliminate toil with automation. We're not going to onboard a system into SRE until it's stable. And if a release impacts the long-term stability, we're going to hand it back, assuming that there is somebody there for us to hand it back to. And product teams will always be involved in the running of live systems. They will always handle 5 to 10% of incidents, which is another form of back pressure. So sorry, slightly over time there, but got there in the end. Any questions?
First of all, thank you so much, Steve. This just confirms that, yeah, the world is complex and the life is complex, actually. There was a saying, life runs on code, which turns out to be actually life runs on DevOps.
Absolutely. I like it.
Is there such a thing as a DevOps, as a career, as a profession? Because people tend to use this, you know, I need a DevOps in my team. What is that?
So I mean, I'm asking this, you know, I run a DevOps company, so we tend to talk about people as cloud engineers, you know, or DevOps engineers, or a combination of both. I wish that we'd never created the concept of a DevOps engineering role. I think that It's still an operations engineer, a systems administrator, whatever you want to call it. But our role is evolving, and we are now using a different set of tools. You know, in the same way we went from physical servers to virtualized servers, you know, to running hypervisors and virtualizers. We went from local storage to storage area networks, you know, and we acquired different management tools at each part of that journey. And now we're moving to the cloud, where we're just acquiring a different set. But if you remember the diagram with the Lego blocks, you know, if you're going to call somebody a DevOps engineer, do they understand infrastructure as code? Do they understand source control? Do they understand infrastructure as code, configuration as code, policy as code, et cetera, et cetera, et cetera, and layering on different levels of specialization on top of that. But, you know, if there's a one takeaway message for the ops people in this thing, you know, you're not going to be expected to become a developer, but you are going to be expected to acquire development skills. That is the future. Right.
Thank you for that. I think we have time for one more question, which is, can you please elaborate? Microservices are the worst pattern architecture ever developed. What is the approach or alternative for this?
So I'll expand on that. That's probably me hyperbolizing. The point is that imagine you shard that system into 100 different little individual components, and knowing that that's going to increase the complexity, knowing that's going to impact the stability and availability of the system. That's just maths. But you leave that system still all in the hands of your traditional operations team that is already overloaded with work, that is already running around trying to put fires out, that doesn't have time to do the projects and the make the world better stuff. Come back to those SRE principles, have time to make the world better. If that's the model that you're doing, you're trading off simplicity for the developers to have this focus on a small bounded context of a nice microservice, and trading it off against a massive increase in complexity for operations. So what I would say is, I think microservices are brilliant as long as you are doing that combination of the organizational design and these long-lived teams, and implementing, you know, bringing a little bit of dev into ops and bringing a bit of ops into dev, and following those DevOps principles. I absolutely agree that microservices is the right way to go, but you've got to do both. You can't just do the splitting it apart. And that's what I see in a lot of our customers. It's become catchy. It's become, oh, we're going to fix our system by turning it into microservices. Actually, you're probably going to make things very badly worse until you look at the automation, the organizational design. Microservices is not just an application change, it's a DevOps change. And you need both parts of that equation to be working effectively for it to be successful.
Yeah, not to mention the costs involved. You were describing very, very precisely that the fact that you have more microservices will decrease the availability. If you want to add back some nines there, this could cost a lot.
Yeah. I mean, you know, the bounded context of a single microservice, I think, makes going from 3 nines to 4 nines to 5 nines easier, because you can understand, you know, within that mental model, within that one small bounded context, you can be, it can be easier. And certainly the cloud, you know, and using of containers and orchestrators like Kubernetes and all of the high availability platforms that are available in the cloud make that easier. But yeah, it's not exactly necessarily going to be cheap. Yeah, absolutely. Okay.
So Steve, it's been a real pleasure. We're looking forward to have you next time at Code Camp, and hopefully meet you in person at some point.
We could hopefully MVPRD Summit one day if we're 2022 or something. I think is the next one. We might be in person. But okay. Yeah, thanks for having me, everybody. I hope you enjoyed my session.
Thank you so much. We absolutely did. Have a nice day.
Bye.